Hello, everybody. Lovely to see you all. We're going to be starting in a few minutes' time. I just want you to double check that you've got all the equipment that you need. So you need some Play-Doh or plasticine, or if you haven't got those things, blue tack will also do the same. Anything you can mold and change the shape. The other thing you need is a bowl or a Tupperware container filled almost to the top, leaving about 2 centimetres, fill it up with water. And then we're ready to roll. So let's just wait until everybody's joined us that wants to. So we'll give it a couple of minutes. Give us a like if you can hear me and leave a comment with your name and your age. And we'll all say hi and then we'll get going exploring marine engineering today. I'll give you a few minutes to gather all those things and then we'll get started. Fantastic. Hello, everybody. We're going to get started in just a few minutes. We'll just wait for everybody to get a chance to join and then we'll make a start. All you need for today's session to do our challenge is some Play-Doh or some plasticine. You don't need loads, just one tub like this or half if you're sharing with siblings. Play-Doh or plasticine and a tub of water. Okay. You'll also need towards the end of the challenge, for the main part later on this afternoon, some paper. Okay. Give us a like if you can hear me. Leave a comment with your name and your age and we'll say hi. Fantastic. I can see we've got quite a lot of people joining us today. That's so exciting. I'm so happy to be here today, everybody, exploring engineering together. Hi, Poppy. Nice to see you. I'm so excited. Have you got your plasticine ready? Good. Okay, great. Hi, Trinity. Nice to see you. Hi there. I hope you're just as excited as I am to get started today. Fantastic. You've got everything ready, Poppy. That's good to hear. Okay, everybody. First, let's start with a little introduction. I'm going to say my name. I'm Lois and I work for the STEM Workshop. And I work here in the Midlands doing workshops all around schools and organisations and also events. And my colleague, Leanne May, or Miss May, she also works in Shropshire, but we also travel here, there and everywhere, all over the country, doing really exciting, fun STEM workshops with young people and children, linking STEM to our everyday lives and also jobs for the future. So, hi Lacey, nice to see you here joining us. That's fantastic. Looks like everybody. Hi Evie and Seb, nice to see you here. You excited? Fantastic. Give us a like if you're excited. Hi. Okay, fantastic. So, to introduce myself, I'm Lois or Miss Hale, and I work for the STEM Workshop. And I'm going to give you a little taster of the kind of things we do in our workshops today. What our workshops involve is exploring STEM. Okay, does anybody know what STEM stands for? Have a comment? Tell me. Oh, I'm glad to hear you're all so excited. Fantastic. What's STEM? What does it stand for? Good. It's science, technology, engineering, and maths. And what we do at the STEM Workshop is we bring all of those subjects together in a practical, really fun way so that you can explore and apply your knowledge of them all together. And that's what we're going to do today, exploring marine engineering. Okay, fantastic. So many of you knew that already. Well done. So today we're doing marine engineering. Now, can anybody have a guess at what that is? Good. It's making products or objects that can be used out at sea. So, for example, boats, and that's what we're going to look at today, boats. And so we're going to explore the science of forces and the engineering of manipulating materials to make them do something that you want them to do. In this case, our boat, we want to float. So I want you all to take your lump of plasticine, and first I want you to roll it into a ball. Okay, everybody do that now. And to do it, you just make a sandwich, your plasticine between your two hands, and roll it like that into a ball. Okay, everybody make your plasticine or your Play-Doh into a ball. Doesn't have to be perfect. And now, our first test that we're going to do is to see if this floats. Okay, right. If you haven't managed to get any plasticine or Play-Doh yet, you've got plenty of time to grab some. So just run and grab some now. Okay, all you need for this is just a piece of paper to use later, some Play-Doh or plasticine, or a bit of blue tack, and a bowl of water. Okay, so if you're not quite ready, no problem. You've got plenty of time to go and grab a bowl of water, even if it's just a cereal bowl, and something you can mould. So Play-Doh or plasticine. Okay. If you've got your ball made now, I want you to test it. Does it float? Before you do that, I want you to think in your head of a prediction. What do you predict? What do you think's going to happen? Do you think it's going to float, or do you think it's going to sink? Okay. And then after 3, we're going to drop it into the water. Don't drop it from too high, especially if you've got your computer nearby. We don't want any splashes getting on your computer or your device. So don't hold it too high. Right. Oh, we've got some people think it's going to sink, and some people think it's going to float. I'm so excited to find out. Right, after 3, let's test it all together. 1, 2, 3. Drop it in. It sinks. Grab it quite quickly, because especially the shop bought Play-Doh, it can start to dissolve a little bit and go a bit gooey. So fetch it out nice and quickly. And what happened? It sank. Sank. Now, if I told you that we could make this float, do you think I'm telling the truth? What do we think? Comment. True or false? I can make this Play-Doh float. Let's see. Let's try and make it into a different shape. Can anybody suggest a shape? Have a go at home. Make it into a different shape. See if we can get it to float. Has anybody got any ideas at home about what I might do? A square. Good idea. Square. Let's try. Everybody try at home. Have a go. You can either do a square with me, or you can do your idea. So now what we're doing is we're exploring and experimenting with our Play-Doh to see if we can change the shape to make it float. So we're being engineers right now. We're manipulating it to make it do a job, to make it float. Right. I've done mine as a cube. Okay. Let's see. Does it float? What do you think is going to happen? It sank. What do I do then? Right, somebody said a flat square. Right, okay, so I'm going to squash it. You do this with me. See if we can make it flat. Fantastic. I can see so many of you are so excited about this. Me too. Right, I'm making it flat. What do we think? Is this going to work? If anybody at home has managed to get their Play-Doh to float yet, do tell me. Oh, nobody so far. Okay, Miles has. Miles has managed to get it to float. Tell us what you did, Miles. Right, I'm making it flat, a flat square. Like a cylinder. Wow, very exciting. A cylinder shape we can get to float. There's some ideas for everybody else at home that's still trying. Right, I've made mine flat and square-ish. Okay, should we try it? Yay! Oh, it floated for a little bit. We're on the right track, I think. Okay, what do I do next? So I watched it, and what happened was it floated, and then the water went on top of it and made it sink. So a square is very hard to make. Yeah, let's try giving it sides. To stop the water floating in. I'm starting to get in a mess now. I don't know if you are. My Play-Doh's starting to dissolve. If your Play-Doh's starting to go a bit slimy, if you've got any more, just grab a fresh piece. If you don't like getting quite so messy. Fantastic! Jack's made a boat shape and it worked. Fantastic. Well done, Jack. Fantastic. Right, I'm going to try and make a boat shape then, Jack, and see if I can get it to work. Wow. Mine's gone all slimy now. I'm going to give it sides like a boat. Right, let's have another go. No, not worked. Well, the theory behind this is all about forces. And what I'll leave you to explore and experiment while I do some explaining a little bit more about forces. So I wonder, why does it sink when it's in a ball, but the same plasticine can float if it's in a different shape, if it's in a cylinder or if it's in a big open flat shape or a boat? And that's all to do with forces. Okay, and the forces that act on this to make it move and do things, there's two of them. We've got weight. Give us a like if you've ever heard the word weight. The weight of the plasticine. Okay. Good. Good. The weight of the plasticine is pulling it downwards like that. And we've got another force that's trying to make it float. Okay. And that force is called upthrust. And we can represent that with some arrows. So these arrows here are showing that the water is pushing up against my Play-Doh, okay? And the weight of the Play-Doh is pushing down. And the key to getting your boat to float is making sure that these are equal, okay? And we can do that by spreading out our shape. So at the moment, when it's a ball, there's not much surface here touching the water. So there's not much water to push back. But if I spread it out wider, we make the surface bigger. So there's a bigger area for the water to push against. And that's the key to making it float. So fantastic. I can see some of you have made boat shapes and bowl shapes. Fantastic. Well done. Orlando suggested a boat shape earlier, and we're starting to see these starting to work. That's really fantastic. So you've done it. You've been an engineer. You've changed something. You've changed the shape of a material so that it can do a job, so that it can float. That is marine engineering in action. Okay. And what I'm going to do now is I'm going to set you a challenge. Okay. And I'm going to give you a new material. And that material is paper. Okay. This is where the paper comes in. So using what we've already talked about, what do we think? Do we think this paper is going to float like that? Okay, what do we think? Give me your predictions on the comments. Tell me, do we think the paper's going to float? No. Oh, interesting. It's not very boat shaped, is it? But it has got quite a big area for that water to push against, and it's quite light. Oh, everybody's saying no. Let's see then. Oh, I can't wait. If you've got some paper that's small enough to fit in your bowl without touching the sides, have a go at testing it. Otherwise, you might want to just snip a little piece of paper that's small enough so it doesn't touch the sides. Yeah, or rip a piece. That's a good idea. And see if it floats. I'll give you a minute to grab some paper. Okay, Orlando, what a great answer. Orlando thinks yes, it will because it's flat. I can't wait to see. Ooh, the idea of folding some paper, Nicola. Good idea. Okay, so I'm going to test it. Are we ready? Have we all got paper ready? After 3, let's test it. 1, 2, 3. Ooh. Mine's floating. Interesting. So that's forces in action. It's flat and it's spreading out across the surface of the water so that all of the upthrust from the water can hold it up. Fantastic. So many of you made a prediction and said no, but it does. Wow. What a mystery. That is forces in action. It's very light, so there's not much weight, and it's very flat, so there's more upthrust here pushing against my paper. Wow. Who knew? But I don't know about you. My paper's starting to go a little bit soggy. Yeah, fold it, scrunch it, loads of ideas. Wow, I can't believe it floats. Now, your challenge is to make a boat using your paper. Now, there are going to be a few challenges here. You're going to have to manipulate your paper, change the shape of it to make it look like a boat, and also to last a bit longer, because I don't know about you now, but now my paper's gone all soggy and it's starting to sink and it's starting to go floppy. Okay, I balanced a Play-Doh on it and it didn't sink. Amazing. Wow, can you believe that? The wonders of forces surprising us every day. Okay, so we're going to take this to the next level now, and you're going to become a yeah, it does. It feels like tissue paper now. It's going really thin and flimsy. So although this will do as a boat, I wouldn't really go out to sea on it. Would you? No, I wouldn't be going out to sea on a piece of paper. So we need to make it even better. Okay. What can we do to this to make it even better? What property does this piece of paper need to make it even better? Maybe, does the paper need to be waterproof? It's all about gravity and forces. That's right, Zach. All about gravity and forces. So weight is the force of gravity pulling on an object. So a heavier object has got more weight because there's more of it to be pulled down by gravity. Absolutely. So I think the key to this paper working is the fact it's got very little weight, but it's got quite a big area to float. Okay, so now, I've got lots of ideas popping up now. Layers, sides, put glue on it. There's loads of different materials. So I'm going to leave you now to explore that further. Put all of those ideas into action. Make your own boat. Take a picture of it and then link it into us on social media at the STEM Workshop or hashtag the STEM Workshop. Make sure we're tagged in your posts of your pictures, and then you can be up for a free prize draw. So we're going to give out a prize to the best photo. That can be you exploring forces. It can be a really creative boat with lots of wonderful engineering. We want the best picture, having fun, exploring, experimenting, and coming up with a really, really great product. Tag us into your pictures and see if you win that prize from the STEM Workshop. So if you've enjoyed this this challenge, we're going to be here same time every Thursday with a new challenge. And if you enjoyed the marine engineering, we have a tutorial on our YouTube channel where you are as we speak, and that's in making a sailboat. So it's taking it to the next level, engineering a sailboat out of cardboard. So if you've enjoyed this activity and you've enjoyed marine engineering, you can go on and there's another new tutorial to take it to the next level. Otherwise, have a really fantastic time making your boats. You're very, very welcome. I have had such a fun time here with you this afternoon. I'm so glad you've had a good time exploring forces and exploring engineering. Next week, we're going to be using plastic bottle, balloons. You might want a couple of plastic bottles, maybe two, because not all of them work. Couple of plastic bottles, 2 or 3 balloons, and a jug of water. And we're going to be using those to make a water jet. Okay, and that's exploring the science of pressure. Okay, so have a really, really great time exploring marine engineering. Tag us into all your pictures of your boats, and you might be in to win a wonderful prize. Bye, everybody. Well done. I hope you had a really, really, really wonderful time. I know I did. You've done a great job, and I'm so proud of you for making your big lump of plasticine float. Okay, now apply what you've found out to your boat. Okay, bye everybody. See you next week.